New packet, day 125 is today, going for another 4 days after this, so it's not a terribly long chapter. We have the study guide here with the answers right after it, if you want to look at that at any time. And let's see here. Well, it's all about weather forecasting. We've talked about weather in various regards, but this is how more daily forecast kind of things are made rather than storms and all of that. And let's start off with a rather complicated graph table that is found in, let's see, I think this is weather.com, maybe AccuWeather, one of those kinds of places. And we're going to learn how to read this, and then we'll go on to some notes. The purpose: I will learn the symbols of fronts on the weather map. We've already done that in the past. And you will learn how the jet stream relates to weather. The relevance: I see these things on weather maps each day, and it'll help me plan my days. Success: I'll be able to interpret a weather map to predict tomorrow's weather. So here we have a chart that has all sorts of information here. We have, look at these symbols of sunshine and cloudiness and rain, and then above here we have temperatures that go up and down, up and down, up and down, and we have the dates, and then we have all these lines down here. Notice that this line is labeled as temperature off to the side here. This line is labeled as pressure, and then we have this gray line that's labeled as chance of precipitation or chance of snow. Here we have a line of arrows, that's going to be wind speed. So, let's see here. On each column, we have the two temperatures. So that's going to be the high temperature and low temperature. That's easy. How cloudy or clear the sky is going to be. And then we have this line here, temperature, going up and down, up and down, up. Why does it go up and down and up and down so much? Andrew?
Day and night.
Yep, cooling off at the nighttime. Notice it's the hottest right around late afternoon. Yes, sir?
Is the flying saucer on your desk?
It is not. It is somewhere in those cabinets.
That is fine.
Let's see here. What's the next? Okay, so that's temperature. Pressure. Air pressure, chance of precipitation, chance of snow. So it starts off here at 0. It has a little blurb, and it has 0 for a long time. It goes up high. Okay, this line here is a little bit different. It has all sorts of arrows, and the arrows go up and down. Notice this is wind speed. So this is showing us not only how fast the wind is. Here we have 0, 10, 20. It's really faded there. I'm sorry for the photocopy. But anyway, up and down, how high the arrow is, that shows us how fast it's going to be. Starts off at 0, then we have 10 miles an hour, 15, back down to 10, and so on. But the arrows are showing us what direction the wind is blowing in. So it's going to the east, southeast, more south, almost north here, etc. So, number 1, what's the expected weather for Monday? Let's see here, 3/23. What's that? March 23rd. Cloud cover is clear. Monday, see, clear. High temperature for Monday. The left-hand number, the bigger number, 39. Low temperature, 23. Chance of rain. That's down here on this. It's flat right at the bottom, 0. 0%. Wind on Monday coming on down. It looks. Here's the wind coming across about 10. Okay. So you've probably already seen this. I should have had it hidden. Oh well. Wednesday, right here. Mostly cloudy, means more clouds than blue sky. Partly cloudy means more blue sky than clouds. High temperature 49, low temperature 42. Chance of rain, that's going to be this gray line here. We see that on Wednesday evening it peaks above this horizontal line. The horizontal line is 25. This goes just a little bit higher than that, so I just estimated 30. And then the wind speed, the fastest wind speed on Wednesday is this peak right here. And going across, it's a little bit more than 10, less than 20, so I'm going to guess 15. As Andrew said, number 2, each day we have both day and night represented here. So the photocopy, unfortunately, is bad again. You can't see that the right side of each one of these columns is shaded to represent nighttime, and we can see that the temperature goes down every time it enters into that shaded region to represent the cooling at night. So that's how that works, and we'll be looking back at this kind of a graph a few times during the packet. Next page. Okay, now I remember to cover things up. Ha 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 ha. Okay, make a little note for yourself at the top before we do this class work together. Remember that cold fronts push up clouds quickly. I have a diagram on the board. I will redraw it here on the paper for the people watching the video. So we have the trees and we have houses, trees, and remember that cold fronts are giant masses of cold air that are moving in one direction, such as this. And when cold air moves, it moves like that slime ball that we were working with many, many days ago. Has a rather steep front and tapering off in the back. So when this pushes into warm air, this steep front here pushes up the warm air quickly, forming clouds relatively quickly, which will lead to quick precipitation that we see as a storm. At least oftentimes. That's not every storm, but it often happens. So you get quick precipitation with a cold front, quick rains, quick storms. Now, if we look at a warm front, that's when we have warm air moving into an area. Here's our same tree as before, the same house as before, the same tree as before. Only this time we have the warm air moving in. We're looking at the back side of the cold front now, this kind of a thing. So it's very gradual. And so we have the clouds being formed over a larger area, and we have some wispy cirrus clouds way up here, maybe some puffy cumulus clouds. And then we have the stratus clouds that cover up the whole sky as they're gently being raised up that side. And so this results in much longer all-day rains. All-day snows. I understand that we're going to be getting a all-day snow. Is it tonight or tomorrow? Tonight, I understand. Okay, so with that in mind, I want you to answer these different questions. Team 1 is going to be Nevaeh and Michael. And let's see, then there's an empty seat. Team 2, that's going to be Jayla and Zach. Michael and Nevaeh, and then we have Jayla and Zach. Team 3 is going to be, let's see here, Wes and Tyler. And then Gio, looks like you're all by yourself at Team 4. Team 5, that's going to be Lewis. Team 5 is Lewis and Adrian and Isaac. Team 6 is going to be Kyle and Sam. Team 7 will be Lupe and Austin. Team 8 then will be the last row, Brian and Carly and Andrew. Go ahead and look at that. It's only going to take you 60 seconds, 2 minutes in order to figure out your 2 or 3 questions. For those of you who are on this page 8, and if you don't recognize the states here by their shapes, I completely understand. I want to direct your attention to the previous page where they have the Postal Service abbreviations that will help you out. Wes, put away your phone, please, and let's be looking at the questions that I've assigned to you.
Ask him if he doesn't know what this line is. But he can hear you just fine. I'm pretty sure. Hey.
I'll be ready to go. I'll be ready.
Which questions are we even doing?
Okay, let's see how well you guys did. So, Michael, on the weather map, what's the symbol for a cold front? Okay, the cold front is the triangles. I think of the triangles as icicles on a cold winter day on the edge of a roof. Okay, symbol for a warm front, Nevaeh. Half circles, yes indeed. Let's make this a little bit more dramatic, more pointy here for the triangles. Make it more obvious. And then round. I think of the warm front as the warm sun coming up over the horizon. And the triangles are the icy icicles on the roof line. Okay, back to Michael. Triangles and semicircles point to show what? Yep, the direction of movement. Zachary, on a weather map, what does the L mean? Low pressure. What kind of temperature does that mean, Zach? Yep, high temperatures. They are opposites. When you have high temperatures, hot air, it's going to rise up. The rising air doesn't push down on the ground very much. Jayla,
Yeah.
what does the H mean?
High.
High pressure. What kind of temperature is that? Low temperatures. So when you have cold air, that contracts. Every gallon of air is heavier than warm air. So this heavy, cool air is sinking down, pushing on the ground harder. So the cold, low temperatures have higher pressure pushing down on the ground. Number 8. We're up to you, Wes. On the map, what states have a cold front moving through it? Yep. We could add to that Kentucky, Tennessee, Alabama, Mississippi. All of those would be just fine.
Alabama.
Okay, and Tyler, where's the cold front? Or which way is it moving? Here are the triangles. Which generally direction are the triangles pointed towards? East. Number 10, Gio. On the map, where's the warm front? Okay, the warm front, I think of the warm summer sun rising over the horizon, like this right here. So it's going to be Michigan, New York, Vermont. And these things are pointed towards the north, and so that's the direction that the front is moving. Number 5, Lewis. Which will have more storms, do you think? The warm front up here in the New York, Michigan, or the cold front going down the middle of the country? The cold front. As we said before at the very beginning of the notes here, cold fronts push up the warm air more quickly, make quick storms. So here are all the states that are having the cold front. These are the ones down here. Wisconsin, Indiana, Kentucky, Tennessee, Alabama, Mississippi, maybe a little bit of Louisiana. Okay, Adrian, which state in that map that we just saw would have all-day rains?
I don't know.
It'd be the warm front at the top. That would be Michigan, New York, maybe Vermont. That's the part that has the warm front symbols of the semicircles. Warm fronts more gradually go over a cold cold air, gradually building clouds, making long-term rains. Okay, next, Kyle. On the map above, which state has a cold front moving through it?
I don't know.
Okay, cold fronts are the triangles. So we have down here, we have Texas, Mississippi, Alabama. Oh, not A-R, A-L. And let's see here. Kyle, can you tell me which way this front is moving?
Southeast.
Southeast. On the map above, which has a warm front moving through it, Sam. Oh, where's the warm front moving? So it's going to be right in this location. We have a little bit of Indiana maybe, and then Kentucky and Virginia. Indiana, Kentucky, Virginia. This right here, that's the warm front. Which way is that moving, Sam? Is that moving north or south? The circles are pointed on the north side of the line, so it's moving north.
Wait, isn't it Ohio?
Oh, yeah, a little bit, yes. Ohio as well, OH. Okay, which state will most likely have storms? Storms, remember, are coming from cold fronts. So, Lupe, which state? Oh, rats. I'm sorry, I kind of called things wrong there, the wrong group. I apologize. Team 8, that's going to Carly. Which one will most likely have storms, this warm front or cold front? Cold front. So up here, the Kentucky, Virginia is more likely going to have storms. All-day rain, Andrew.
Texas?
Oh, let's see here. I think I just said something wrong. When I said storms, did I say this row right here? Is that what I said? Sometimes I'm thinking 3 different things up here all at the same time and I get mixed up. So let's backtrack to make sure that we have it all right. My writing is correct. What I had said a moment ago might have been wrong. Storms are from cold fronts. Cold fronts are shown by the triangles, the cold icicle kind of a symbol. So that's going to be Texas and Mississippi and Alabama here. Arkansas maybe too. All-day rains, that's from the warm front. Warm fronts are shown by the warm summer sun rising over the horizon. So that's this one right here, Indiana, Kentucky, Virginia. So that kind of a forecasting thing we've done in the past. All of the stuff that we've just covered is in previous packets. Let's look at this video here. How does a cold front?
Yeah, well, it's the kids that ask the great questions,
Right.
and I just scramble and I talk to other kids to get the answers. Not that part, but we actually share some good information. When I went to Eagle Middle School this past week, I'm going to go back again in April to talk to some of the other kids as well. Had some great questions, and here's a great question, and I'll have an explanation of why this question is being asked.
My name is Taylor Aaron, and I go to Eagle Middle School, and my weather question is, how does a cold front bring thunderstorms and clear weather?
Taylor, great question. What Taylor was meaning is, as she was doing research on cold fronts, she would see some books say that cold fronts bring precipitation with it, and then other research saying cold fronts bring clear weather. She was a little confused on how exactly does that work. Well, what it's talking about is depending on at what part of the cold front and what's the overall forecast after a cold front passes. So here's what a cold front looks like, a cross-section. If you were to slice the atmosphere, there's the blue line I was showing earlier today, the cold front coming on through, and as these track to the east, or whatever direction they're heading in, behind it there's drier weather, but because it's cold air that's coming in, cold air is heavier and denser, and so it stays close to the ground. As it does, the warm air out ahead of it, like we had today, rises, and that rising air cools and condenses and makes clouds and precipitation. So we have lots of showers today and even some thunderstorms because the air rises rapidly and violently just ahead of the cold front. So we had thunderstorms and thunderheads developing just like this. Well, once the cold front passes, the air is sinking. You see these arrows here. That air is sinking and it tends to dry out. So fronts will bring precipitation with them, but they also bring the promise of clearing skies behind, and that's exactly what we're seeing tonight. We have the showers and precipitation. It is all moving to the east, and now we are drying out as that cold weather moves right back in. So guys, this was a great question and a great answer, and it was timely. I kind of thought we would have a front coming through tonight, so we timed that question for tonight to show.
Okay, enough of that. Next page. New material now. Will a front bring rain, snow, or sleet? You have to remember that clouds are not all the same. Some clouds are made out of ice crystals. Some are made out of water droplets. Either way, they're suspended up in the air. Depends upon how cold things are up there. Precipitation can fall through layers of air with different temperatures as the stuff comes down. So on this, we're going to have quite a complicated little diagram here. Let me get a new picture for you so that you can see me draw it along with you and that doesn't get too overwhelming here. So, let's first label this cloud here made out of droplets. This cloud is in air that's warmer than 32 degrees. It's kind of close to the warm ground. These clouds up here are in a higher elevation where it's colder than 32 degrees, and so this is made out of ice crystals, basically snowflakes. I read once that most clouds are made out of ice crystals. Don't know if that's true or not, but I read it once. Okay, so when this cloud has its raindrop or droplets get big enough and heavy enough, they're going to fall, and they're going to just fall on this person as rain. The ice crystals, they gradually collide together, they stick together, the ice crystals get bigger and bigger into snowflakes, and it's going to eventually get heavy enough to fall down, and it starts to fall as snow. However, that snow falls through air that's warmer than 32 degrees, and so this can then melt in the air, and it can hit this person as rain. Some of the snow can fall through here. It can melt, become rain, and then, now this is in the warmer than 32 air, it then falls through another layer that's colder than 32. This ground is colder than 32. The ground is colder too. And so the rain here, it's still rain. It's not in the cold air for very long, so it can't freeze. But once it hits the ground, it freezes. And we call that freezing rain. it coats the trees with ice. It covers the power lines. It can break them because the ice gets so heavy. So, freezing rain. It freezes, rain freezes on the cold surfaces. As it's coming down in the air, it's water, but as soon as it hits the cold surface, the cold tree, the cold power line, the cold car, whatever, the cold road, it freezes. Okay, then we can have snow come out of the cloud. Snow, there we go. It then melts into rain when it comes into this section of warm air. But then it's falling through cold air again. So the drops are going to freeze. Little pellets. Little peas. Like styrofoam. We call that sleet for this person right here. So you hear the old adage of the postman delivering the mail, whether it be rain, snow, sleet, or hail. Okay, this is the sleet. Or the snow can come out of the cloud and it just keeps on going through air that's all cold air, so it stays snow the whole trip down. So we have the snowflakes. These are the pellets. This is the freezing rain. This is rain. This is rain. Jet streams are the next important thing. Knowing the location of the jet stream will help us to figure out what kind of weather is coming.
This is going to be a very short lesson on jet streams. Really goes with kind of the other wind sections that we did, but I didn't have time for it then, so we're just going to do it in a separate little lesson. Jet streams are strong currents of wind located at about the tropopause. It's a strong current of wind located at about the tropopause. Think about them as like a river of wind at the tropopause. Again, tropopause, remember, is the boundary between the troposphere and the stratosphere. So a strong river of wind at that level. You can see in the pictures here, there are 4 of them. 2 in the northern hemisphere and 2 in the southern hemisphere. We have the polar jet and the subtropical jet. And you can see about how big they are, maybe. So they are kind of like rivers of strong wind at the tropopause. Now, how strong is the wind? Well, maybe it's, 120 miles per hour to 180 miles per hour. So it's a pretty strong wind. You notice that these are westerly winds. So they go from west to east. If you are traveling maybe from Los Angeles to New York, and the jet stream happens to be going that direction, the airplanes will get in the jet stream, and that'll help to blow them across. And they can save fuel and go a lot faster. If you're going the other way, going from New York to Los Angeles, then they're going to want to avoid the jet stream. They don't want to have that headwind and be fighting it, so maybe they go above the tropopause or lower, or at just a different latitude to try to get around that jet stream. Well, what causes them, and then kind of why are jet streams important for weather? They're caused by differential heating, which causes pressure differences. So you see in this animation, we have high pressure here, low pressure here. Where they're spinning, it's going to make it really fast going through here. You might have seen a machine like this that pitches baseballs or pitches footballs. And you have 2 big wheels going opposite directions, and you put the baseball or football in the middle, and it goes whoo, really quickly through it. That's basically what the jet stream does. Okay, you have your high pressure, your low pressure, and it speeds going through it. So it goes around the Earth, like I said, it's westerly, it goes west to east. There are about 5 or 6 of these loops usually. Now, how it's important for weather is the jet streams usually separate air masses. So you see in this picture, north of the jet stream usually is colder air. South of it, it's warmer. We look at this big picture again, we think, okay, it's summertime. The Earth is tilted towards the sun in the northern hemisphere. So these jet streams shift upwards. The polar jet stream shifts way up here. The subtropical jet stream shifts way up here, maybe. And in Texas, we are hot, 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 because we're in this really, really hot air. We don't get kind of the moderate medium air, and we certainly don't get the cold air. So our summer is usually very hot, very dry, because this jet stream is way above us. Okay, it would bring the cooler air down, and it would also bring storms. In the wintertime, it's the opposite. We're tilted away from the sun, so these jet streams shift downwards. So the jet stream shifts down this way, polar jet stream shifts down, and we're usually between the two. So we get kind of mild winters. Sometimes, the polar jet stream will actually dip below us. Then we have the really frigid days, where we get, to the teens, and we get the ice storms and things like that. So it really kind of affects the temperature of a location, because these jet streams tend to separate the air masses, and storms kind of follow them. If I click on a weather map, we can see, you can look online and see where the jet streams are on any given day, and they can give you forecasts also for where the jet streams are. So here's one for this day. You see a jet stream happens to be going here. Arctic weather up here. This day is actually January 29th. Today in Dallas, it was only about 30. It was an 18 for a high, but up here it was like -12, -20s. So Arctic weather up here, you can see it separates different air masses. Then they have a forecast for the next day. So you can get forecasts for where the jet streams are going, and it will, like I said, affect the temperature. And that's really pretty much it for our little short lesson.
Okay, now, these black circle arrow things are representing the convection currents that are around the Earth. Let's draw something like that in our notes so you can understand this a little bit better, I hope. So, the jet stream separates the major convection currents going around Earth, and here we have the major ones in the north. This convection current and this one have different temperatures. This one being in the north at the poles, that's going to be a cold convection current, and this one's going to be warmer, and this one's going to be relatively hot. And these convection currents are not static, they're not stationary. They can grow and move back and forth a little bit. When the jet streams are in these places, basically right there. Please put little stars. Okay, so when we are between these two jet streams, we're in the warm convection current. This is the main one that we're concerned about. When it is north of us, then we're in the warmer cell here. When this moves back and forth, and it moves downwards south of us, then we're in the cold section. When the jet stream is south of us, we're in the colder one from the north. So by keeping track of the jet stream, we can know what kind of general weather we're going to be having in the future. When the jet stream is right over us, we expect stormy weather, because that's where the convection currents are lifting the warm air up and making clouds and rain. The symbol for a jet stream varies from map to map, but it's generally a set of arrows or a line of arrows. So you'll see it something like this. And that's the end of the notes. We have Schoology homework questions for you to do at this time.